Okay, so today we're going to be talking about chloride levels, okay? Chloride. And how it affects your overall tank and how it works, okay? So chloride, again, this really works good for people that have the following. You have anodes that are made out of pipe, okay? They contain phosphorus. If you have anodes that are made out of wire or a solid chunk of copper that is not known to have phosphorus in it, this video is useless to you. Another thing is, so people that home brew their electroforming solution, this is a really good video for you. People that have pre-made electroforming solution from like Rio Grande, this video is probably not a good thing to experiment with, okay? Because you do not want to augment the chemical formula that's in the pre-made solution by adding chloride to it. Cool. So, that being said, let's get on with the video. Okay, now I try to sell you on chloride. Why is it important? Well, one, it keeps your tank nice and clean. So you do not have a whole bunch of really nasty stuff at the bottom of your tank. Two, it filters out your copper ions from your anode. Keeps your anode intact as it dissolves. Three, it allows current lines to be smoothed out. So if you have current lines, and I'll show you what those are in a second, you might want to try this out. But before you even start, you should see if you have a chloride problem to begin with. So to tell if you have a chloride problem, one, you can just raise your anode. Look at it. Does it have black on it? The answer is yes. Leave your chloride alone. Walk away. Don't even bother with the rest of this video until it becomes a problem. I would still watch the video because that way if you see the problem, you can diagnose it. Okay? So no black. That's when you have to kind of worry. Don't scrub the black off. The black actually adds a nice filter so that your anode stays intact as it dissolves. It actually dissolves a lot more even in the tank, and keeps out high degrees of oversaturated copper out of your tank. So this is a brand new solution I just mixed a couple days ago. Here's what it looks like after a while. And you can see those are definitely black. The only thing that's in my tank floating around is this black stuff, okay? Very small amount of it. There's no extra crystals growing too much. So this tank was meant to have no texture whatsoever. So you can see to the bottom, there's not a lot of copper per solution. This one has a high degree of copper per solution, so it produces texture. But if my chloride levels were off, what will happen is that texture would be really harsh. Okay, so let's look at examples. Okay, you see these are current lines. And if you are experiencing this and you don't want them, it's probably a chloride problem. Okay? Another thing it could be though, and here's the kicker, is agitation of the liquid. Okay, so if you're experiencing this and your anodes are black, that means you have an agitation problem. Literally, because you're probably getting agitated over it. Okay, so if my chloride levels were so high, this is what I get. And when I was young, like 4 years ago, I came across stuff like this, and I was like, God, I wonder what's going on. And now later on, I find, like, yeah, if you add a lot of chloride to a mix, you get this. Guess what happens? Sometimes when you wash out something, let's say you take your anodes and you rinse them off or something or whatever, or let's say you have your hands with tap water on them and you spray it in your tank, your chloride levels will get high and you'll see this. So it's a contamination error. You might have tap water if you start seeing this, and the tap water contains chloride. In this case, getting chloride out is really difficult. It requires some chemicals and a lot of filtration. It's almost easier to throw out the actual electroforming solution than it is to try to get the chloride out. So with this video, I warn you, I would try this on smaller batches, get used to it, and then play around with adding chloride. If you have black anodes that are copper pipe, don't worry about chloride. If you are using wire anodes or some kind of like scrap copper or whatever, you do not know what's in that. The phosphorus needs the chloride. Okay? So I wouldn't mess around with chloride if you are using wire anodes or if you are using just miscellaneous copper that you do not know what's in it. Okay? Okay, confused yet? Awesome. That's chloride. Yes, you'll get there. Alright, so let's go into this, and we're going to go into math, which is even better. Alright? Okay, so this is your standard formula for electroforming solution, and it goes in degrees, but this one works really well with texture. So I get a lot of texture with this one. If you are using Rotobran, which is 95% acid, sulfuric acid, you use 30 milliliters. If you're using battery acid, you use 80 milliliters. Just to put it in context, this is Rotobran 95%. Okay? I do not have battery acid out right now, but yeah, it's battery acid, 35%. There's no substitute for this at all. So if you are in a different country and you're looking for sulfuric acid other than battery acid or drain cleaner, some kind of weird substitute, there is none. Sorry. But you'd be surprised in, again, drain cleaner and car acid is a good source for this. Just make sure you know what the percentages are. And you can kind of do math correlating around this formula. So our goal is about 60 to 80 ppm of chloride in a solution. Okay, formula number one. I figured this would be good for different countries because all you need is table salt. So for 1 liter, we make a solution. This is the solution that we make. So we add 16 grams, again weigh that out using a scale, 16 grams per 1 liter of distilled water. Okay? Mix that up really good. I just put it in a bottle. Okay? If you add 6 milliliters to the 1 liter, you will get 60 ppm of chloride estimate. And here's how you figure, this is how you use the salt, okay? How the math works. So at 1 milliliter, you get 10 ppm. At 2 milliliters, you get 20 ppm. 3 milliliters, you get 30 ppm. Here's how you scale it up. Again, so if you had 6 milliliters, you get 60 ppm. That's correct. Let's scale it up a little bit. Okay, fun fact. There's 4 liters in a gallon. If I have 3 gallons, 4, because there's 4 liters per gallon, times 3 gallons equals 12 liters. Now, 12 milliliters to 12 liters equal 10 ppm. 20 milliliters, 24. So if you keep this going out, you would get to 60 ppm. And here's how I know it works, because I did some testing on different 1,000 milliliter containers. So at 60-80, it works well. 100 to 200, I get harsh texture, and at 250, you get this. If you're lucky, because at that point your anode becomes so polarized that there is no amount of current that actually goes into the liquid. So we'll call that screwed. Alright, cool. A lot of math, right? Okay, sweet. Let's go into the other section. Okay, muriatic acid can be found in your local hardware store. Muriatic acid, you would need 0.13 milliliters to equal an estimated 60 ppm. Okay, right off the bat. Alright, so I'll just give you a clue on how small that is. This is an eyedropper. And there's my finger. That's 0.25 milliliters. So I need 0.13 would be somewhere in here, equals 60 ppm for 1 liter of water. Now that's really small, so don't go buying 10 gallons of this. You'll never use it. Now, let's talk about muriatic acid versus hydrochloric. So muriatic acid is impure. It has iron. It has all kinds of crazy stuff in it that is not good for your tank. So muriatic acid, you can use this in a pinch. I would probably use salt before I use muriatic acid because of the iron in it. The best thing, the absolute best thing you can do if you're playing with this whole formula is substitute muriatic acid, use the same formula, and get yourself some hydrochloric acid. It's very pure, it doesn't have all the weird chemicals in it. There's a regulation because it's scientific, it's on Amazon, and it's not that expensive. This thing will last me, my great-great-great-great-great-great-grandchildren will have this because, yeah, you don't use that much. So don't buy the big version of this. This is 1,000 milliliters. I would get something really small. Yeah? 1,000 milliliters is too much. So, just say hydrochloric acid and use that 0.13 milliliters per liter. So much math. I love it. So this is why when I had it in my book about chloride, I left it out, because really there's a lot to it. It's not a beginner's thing at all. This is more of an advanced tool, and you could screw up your electroforming solution. So this is the more advanced, I would say. Playing around with it is good for you. You're going to make mistakes, and you're going to find out what the middle of the road is for you. I have need for texture actually, so I go, I do the 60 ppms, and if I wanted to go a little higher I could, but I stay around that, so maybe 40 to 60 ppm is what I'm doing right now. That's if you want texture. If you just did this formula with hydrochloric acid, I think you would be very happy with the results. Alright, so that is the long story about chloride. So I hope you enjoy.